Hello and welcome. My name is Ognjen Petrovic and I am an applications engineer at Typhoon HIL. In this walkthrough, we will be focusing on the new features and improvements included in the 2025.3 software release for Typhoon HIL Control Center. Join us as we explore more details of what this release has to offer. In this software release, we have introduced a new communication protocol that improves the digital substation testing capabilities, the IEC 61869 Sample Values Communication Protocol. We have used the international standard IEC 61869-9 Instrument Transformers, Part 9 Digital Interface for Instrument Transformers as a reference in implementation of this feature. This standard is an official extension to the IEC 61850-9. The whole SV protocol is defined by using three components from the schematic editor Library Explorer: IEC 61869 SV Setup, IEC 61869 SV Publisher, and IEC 61869 SV Subscriber. The mentioned SV Setup component can be used to set the Ethernet port that will be utilized for this communication protocol, or to manually specify the last digit of the MAC address. Remember that if IEC 61869 SV protocol is used in the model, there must be exactly one setup component for each HIL device that uses the protocol. When you open the IEC 61869 SV Publisher's Component Properties window and open the Application Service Data Unit tab, ASDU for short, you'll see that you can specify parameters for all ASDU fields inside the Application Protocol Data Unit: the publishing message, such as SV identifier, scaling for current and voltage input signals, or whether the synchronization is static or dynamic. With each publisher, it is also possible to choose which variant will be implemented by the component. You can play with signal quality or dataset specifications and even configure the SV publisher using an SCL file. The IEC 61869 SV subscriber component is used for subscribing to an application protocol data unit field, APDU field for short, from a certain SV message on the network. To subscribe to an SV message, the APP ID and SV ID must be specified for message filtering. Note that the APP ID value is used to filter the SV message from the network. Other than that, you can define the scaling factor for voltages and currents, and in the Dataset tab, specify the number of current and voltage quantities in an ASDU field of the receiving SV message. On SV subscriber components for both IEC 61850 and IEC 61869 protocols, you can now find ports for monitoring SV message fields. The SMP count output gives us the index of the SV message. Through SMP sync, you can find out the synchronization mechanism of the clock used for receiving the SV message. And finally, by using the simulate output, you can detect if the SV message is sent by a test device. Of course, if you wish to learn more about how these components are configured and used, or how the IEC 61869 SV communication protocol has been implemented as a whole, please refer to documentation links below. In this software release, we have extended functionality of various interface components. For the SPI slave component, we've added the daisy chain functionality, which you can turn on by checking the checkbox. Once checked, simply choose how many devices with SPI capability you want to include in the daisy chain. For ISO 15118-20 EVCC AC, we've added support for AC and AC BPT energy services. Additionally, we added Ethernet port selection for several components: Modbus client, ISO 15118-20 EVCC, ISO 15118-2 EVCC, and ISO 15118-2 SEC. The BMS HIL interface is our all-in-one solution for testing battery management systems in electric vehicles and energy storage. It combines real-time simulation with physical smart cell emulators, allowing you to safely validate BMS performance, protection, and balancing without using the real batteries. This platform supports a wide range of battery chemistries, voltages, and communication protocols, making BMS development faster and more reliable. With the latest upgrades to our component and new features, we are enhancing software support for the BMS HIL interface, merging both software and hardware elements into a seamless, integrated solution. Let's dive into these upgrades now. Battery Cell Components has received new Emulator tab in the Components Properties window. This addition will help you to link battery cell components to physical cell emulator channels. Emulator measurements such as voltage, current, and temperature are available in the Measurements tab. Another great addition to this component is the availability of a choice between an electrical and series spec-based interface. This can be quite helpful since choosing the latter can help you reduce the utilization of voltage sources in your model, particularly in cases when you are using large numbers of identical cells in series. In the library of the newest version of THCC, you can also find a new battery pack component, which you can use for easy building, parameterization, and interfacing with the physical interface of the entire battery pack. In it, you can specify pack configuration and generate hundreds of parameterized battery cells by one click of the Build button. Using this component should be intuitive, since we took great care in keeping parameterization the same as in the battery cell component, with parameters impacting all created cells. Interfacing with cell emulators is also done in the same manner as in the battery cell component. Another welcome addition the 2025.3 software release is bringing to Typhoon HIL Control Center is the new set of diagnostic features for FMU Import component. Firstly, we added the status port, which gives us status messages like OK, error, warning, and so on. This, of course, can help you detect potential FMU issues. Secondly, a logging option was added. By enabling it, you can record FMU log messages to a log file inside the target files folder. It includes status messages, solver info, simulation time, etc. To enhance the user experience while typing the code, we've integrated Typhoon API autocompletion for Python code editors. This is available in Schematic Editor, HIL SCADA, and Typhoon Test IDE. While typing, function docstrings, documentation, and code examples for different recommended functions will be visible to you by hovering over them. The TyphoonSim library is still growing, with more components being supported every update. With the 2025.3 software release, semi-ideal switches are added, as well as 20 new converters, such as bidirectional choke, phase-shifted full bridge, active clamp flyback, among others. Additionally, start delta stator windings connection is now supported for all machines in TyphoonSim. Beyond this, in TyphoonSim, full saturation support for PMSM VBR type machine model is available, as well as incremental inductance mode for PMSM and saturable leakage inductance support for DFIM. Thank you for joining us on this release walkthrough of our 2025.3 software release. We invite you to test out these new features in your projects and provide us with your insights and experiences. For more information and updates, stay connected. Thank you for watching.
Check the video description for more resources on this topic, including how to download and get started with Typhoon HIL Control Center for free. You can also visit HIL.academy to access free courses, expand your HIL testing skill set, and get certified. Subscribe to our channel to get notified about new content.